Good morning, this is your third lesson on exponents. So as a recap, the very first one is x squared times x to the fourth, and you're adding in that scenario, so the 2 and the 4 become the 6. When it's above it, you're multiplying it, so the 2 to the fourth power raised is the times, where it becomes 8. And your newest one is when it's a division. So you have x squared divided by x to the first. So you're going to subtract those exponents. Remember, the bases have to be the same. The x's have to be the same. So 2 subtract the 1 becomes x to the first. And then the whole numbers that are before it, x or 3 to the second divided by 3 to the second. You keep your base. So 3 is your base, and then you just subtract the 2's, and then it becomes 0. And then don't forget, any number to the 0 becomes 1. And that goes for if you didn't have the exponent, like 3 over 3, if it's just a regular math problem, would become 1. So it makes sense that the 3 to the 0 is 1. In this scenario, you could still do the 3 to the first over 3 to the first, and you subtracted them, and you get 3 to the 0, which is 1. So then, if you have a different base, 13 over 4 with the x to the fifth, x to the second, that 13 to the fourth to the over 4 still stays. You cannot subtract 13 over 4. If it were a math problem just like this, without the x's, it would still be the same fraction. But then I have the bases beside it that are the same, so I apply the subtraction rule. So 5 subtract 2, still 13 over 4, and then x to the third. So then here's this one. So I have the 4's, the bases of the 4's are the same, so I'm going to subtract the exponents. So the 2 subtract the 4 becomes 4 to the negative 2, and then the 1 subtract the 2 becomes x to the negative 1, and then the 3 subtract the 1 becomes y to the second.